The space between two square flat parallel plate is filled with oil. Each side of the plate is 60 centimeter. The thickness of oil film is 12.5 mm. The upper plate, which moves at 2.5 meter per second, requires a force of 98.1 Newton to maintain the speed. Determine dynamic viscosity mu of oil in poise, kinematic viscosity of the oil in Stokes if the specific gravity of oil is 0.95. So guys, first we have to understand that what is given in the question and what we have to find. So here it's given like a two square flat parallel plate filled with oil. So in the diagram, this is a square parallel plate. Okay, these two plates is parallel. Okay, this is a sectional view of the plate. Okay, it is a sectional view of the plate. Section A. Here is the top view of the plate. So top view, like it is a square plate. Each side 60 centimeter. Okay, here in the question is given each side of the plate is 60 centimeter. So each side of the plate, all four sides is 60 centimeter. So I have cutted down the section here. It's a sectional. It's a sectional view. So here the two. This is the top plate and this is the bottom plate. These two are the parallel plates. Okay, in between this oil is filled. Okay, the thickness of oil film is 12.5 mm. So the thickness of the oil film is 12.5 mm. Okay, these are black dot line you are seeing. It is the oil filled. The upper plate, which moves at 2.5 meter per second, requires a force of 98.1 Newton to maintain the speed. For the maintenance of the speed, to maintain the speed, okay, this top plate is moving at a 2.5 meter per second and required a force of 98.1 Newton to maintain the proper speed. Okay, so we have to determine dynamic viscosity of oil in poise, kinematic viscosity of oil in Stokes if the specific gravity of oil is 0.95. So here in the diagram, I will show you. This is mu. Mu is the dynamic viscosity of oil. So we have to find the dynamic viscosity of oil in poise, and this is a V. We have to find the kinematic viscosity of oil in Stokes. Okay, so V is denoted by kinematic and mu is equal to dynamic viscosity. So these two value we have to find. Okay, once more I will explain explain with the diagram. This is the top plate. This is a square plate. Each side is 60 centimeter. Okay, each side is 60 centimeter. The area of the square plate will be 0.6 by 0.6. So we area will be calculated 0.36 meter square. Okay, this is the top plate. I have sectional view is there. This is the top plate and this is the bottom plate. Top plate is moving and bottom plate is fixed. Okay, oil is filled between these two plates. Okay, thickness of the oil is 12.5 mm and we have to find the dynamic mu equal to dynamic viscosity of oil in poise and kinematic viscosity of oil in Stokes. Okay, so these two value we have to find. So now what is given in the question? One, each side of the square plate 60 centimeter. So first we have to convert it into a meter. So we have to divide by 100, 0.6 meter. Second, area of square plate is 0.6 by 0.6 as given in the diagram. 0.6 by 0.6. We have to remove the area. 0.36 meter square. Thickness of the oil film dy 12.5 mm. ठीक है, thickness of oil film which is given in the question, thickness of oil film 12.5 mm. So we have to convert from mm to meter. So we have to divide by 12.5 divided by 1000. 1000 can be written like 10 raised to 3. 10 raised to 3 will come in the numerator and we can write this as 12.5 into 10 raised to minus 3 meter. Okay, so dy will be 12.5 into 10 raised to minus 3 meter. Fourth, velocity of the upper plate u is equal to 2.5 meter per second. Okay, so this is a u. Upper plate is movable plate. 2.5 meter per second is given. Fifth, Force required on upper plate 98.1 Newton. Specific gravity of oil 0.95. Okay, for a kinematic viscosity, specific gravity is given, but for dynamic it is not given. So we have to find it in Poise, and this is in Stokes. So solution. Our regular equation we are using to calculate the numericals is of the fluid is tau is equal to mu du by dy, but we have to here tau value is not given, so here the area is given, so from area we have to remove the tau, shear stress. So tau is equal to force upon area, force is equal to 98.1 Newton, okay, which is given in the diagram, okay, and area is 0.36 meters square. Okay, this is the force required 98.1 and the area of square plate. Okay, so shear stress we will remove, we will got 9.98.1 0.36 by calculation 272.5 Newton per meter square. Tau value will come, okay, shear stress will come. Okay, let mu equal to dynamic viscosity of oil using equation tau is equal to mu du by dy. Okay, okay, so we have to put all the values. Tau values 272.5 Newton per meter square, mu 2.5 meter per second, okay, du is like velocity of the upper plate 2.5 meter per second, so 2.5 meter per second dy thickness of the oil film dy is equal to 12.5 into 10 raised to minus 3. 12.5 into 10 raised to minus 3, okay, du by dy 12.5 into 10 raised to minus 3. But as per mathematical rule, this term in the denominator will come before equal in the numerator, and the 2.5 meter per second will come before equal in the denominator as per mathematical rule. Okay, so we have to calculate this. Meter will got cancelled, okay, so Newton per meter will remain and meter per second. So here 10 raised to minus 3 hai. If it is it come below 12.5, it will become 10 raised to 3, and 10 raised to 3 will be written as 1000. So first calculate in Calc 272.5 multiply by 12.5 divided by 1000. Okay, so what value will get here? It is 3.4 Newton per meter. Okay, by calculation these two, okay, these two and divide by 1000, we will got 3.40 Newton per meter, and 2.5 meter per second will be at bottom. As per mathematical rule, Newton second will come up, Newton second, and meter will down, Newton second per meter square, and by dividing this we will got 1.36 Newton second per meter square. Okay, but we want this dynamic viscosity in this Poise. Okay, we in Poise we have to take, so 1.36 Newton second per meter square as 1 Newton per meter square is equal to 10 Poise. Okay, 1 Newton second per meter 10 Poise. So 1.36 into 10 Poise. Okay, so 13.6 Poise we will get. The dynamic viscosity is 13.6 Poise. 1 Poise is equal to 1 by 10 Newton second per meter square. Okay, 1 Poise. Okay, so 10 Poise is equal to 10 Poise is equal to 1 Newton second per meter square. Okay, so we have got the dynamic viscosity is 13.6 Poise. Now second we have to calculate the kinematic viscosity of oil in Stokes. So we have to find here V, mu we have got 13.6, so we have to write here 13.6 Poise. Okay, now we have to find the kinematic viscosity. Okay, specific gravity of oil is 0.95. It is given in the question. So let V is equal to kinematic viscosity of oil, but before calculation we need to remember some points, okay, because we have to use here the equation which is in relation between the specific gravity, density of oil and density of water. So for liquid where water is reference substance, then the equation becomes specific gravity equal to density of oil divided by density of water, and density of water at 4 degrees Celsius is 1000 kg per meter cube, okay, for a substance like oil. And second, here it is if specific gravity is greater than 1, substance is denser than water, and specific gravity less than 1, substance is less denser than water. So this is the main point. These 2 points is the main. So we have to remember this because we are using the relation between the specific gravity, oil and water. So mass density, we have to remove here the mass density. Okay, mass density of oil. So density of oil is equal to specific gravity into density of water. Okay, so oil will come here, and mass density of oil is equal to density of oil specific gravity into water. Okay, specific gravity 0.95, it is given in the question. 0.95 is given in the question, and 1000 kg per meter cube. So density of oil is equal to 950 kg per meter cube. Okay, we have removed the mass density of oil. Okay, here the relationship between the kinematic viscosity, dynamic viscosity and mass density of oil or any fluid is given by following formula. So any of the fluid will, the relation between the kinematic and dynamic viscosity and mass density of any fluid is given by the following. Okay, so V is equal to mu upon density, where V is equal to kinematic viscosity. We have to find this. Mu is equal to dynamic viscosity, and density is equal to mass density of oil. So V is equal to 1.36 Newton second per meter square, and mass density of oil is 950 kg per meter cube. So meter square will get cancelled. Okay, we will 1.36 divided by 950, we will got this value 0.001435 Newton second kg per meter. So but here we have to understand that 1 Newton value of 1 Newton is kg meter per second square, 1 Newton. Okay, so N will be separately written like this, kg meter per second square, and S, this is S. Okay, and kg and meter. So please don't confuse in this. I have clearly noted down here 0.001435 Newton second kg per meter. Okay, and 1 Newton is equal to 1 kg meter per second square. It is a unit of Newton, so it is written and will be written down separately. Okay, S square kg per meter. So here second with cancelled and the remaining is kg meter per second kg per meter. Okay, 0.001435 kg meter per second kg meter. Kg will get cancelled, and m will be shifted upside. So meter square per second. So v is equal to 0.001435 meter square per second. So we have got the kinematic viscosity which is 0.001435 meter square per second, but we want the value in the Stokes. So for the Stokes we have to remember this conversion. 1 meter square per second is equal to 100 Stokes, and 100 Stokes is equal to 10,000 centimeters square per second, and also 1 meter square per second is equal to 10,000 centimeters square per second. So first we will convert. We have got the value in meter square per second. We will convert this in centimeter square per second. For conversion we will multiply by 10,000. So we will got the 14.35 centimeter square per second by this. Okay. Now we have to convert centimeter square per second to Stokes. We have to divide by 100. As 1 centimeter square per second is equal to 1 by 100 Stokes. Okay, so we have got the value here is 14.35 centimeter square per second. Okay, So now we will divide it by 100. So we have got the kinematic viscosity 0.1435 Stokes. Okay, so we will note down 0.1435 Stokes. If any question, or any confusion in this numerical, then please write in the comment.